Good morning, ladies and gentlemen. We are back again with an interesting video under Unit 2, particularly inference about two population variances. So when you are talking about the inference about two population variances, the inference about the population variance is based on what is referred to as the F distribution, which people may mainly call it the Fisher's distribution table, and these are the assumptions that we are always putting into consideration for you to basically solve the particular information that is needed for the knowledge. So these are the two main assumptions, where the first assumption is the population from which the samples are drawn are normal, and the second assumption is that the two samples are random and independent, which you have this sample called sample 1 and the other one which is called sample 2. Remember, they should be random and independent. So these are the point estimator that we are putting into consideration together with the test statistic, and this is the ratio that is always put into consideration when you are dealing with the parameter of interest in you finding the ratio of the question. So the point estimator in this case is the same as the test statistic, but there is one thing that I want you to know, is that always the one which is on top as the numerator is always greater than the one which is down called the denominator. That's why they have said that the variance 1 is greater than or equal to what? Variance 2. So these are the two main assumptions that we should always put into consideration when you are dealing with inference about the two population variances. So this is the summary table which we will use in the rejection regions. So the one that is commonly used is the guy which is down. So in our studies, I believed we already looked at the inference about two population means, and in the same lecture slide we had already discussed in how you go about in solving example number 1. So my main focus today is us discussing how we were approaching example number 2 in this lecture slide. So this is the example that we are basically putting our focus on. So from a random sample of 5 students, so meaning n is equal to 5. So this is n1. You can say n1 is equal to 5 in a statistics course that uses group learning techniques. The sample mean examination score, so this is the sample mean, so you say sample mean 1 is equal to 79.52, and the standard deviation, which you can say S or sigma, is equal to 5.74. So we can say sigma 1 or S1. Remember, they basically mean the same thing. S is simply the standard deviation calculated from a sample, and sigma is simply the standard deviation calculated from a population. But in this case, let's just denote either S or sigma, regardless of whether it's a population or sample. So for an independent random sample of 8 students, so now n has changed, n has become 8, so we can say n2 is equal to 8. Students is another statistics course that does not use group learning techniques. The sample mean and the standard deviation of the exam scores were, so you say mean 2 is equal to 70.75, and the standard deviation 2 is basically equal to 3.85. So when you are to sum up your data, this is how the data is going to basically look like. So remember, like we said, we do not have the equipments we use in making our videos, so that's the main reason why we are trying to improvise for you guys. So when you go, so going further to the question, it says it is assumed that the populations are normal. So the first question is, at the level of 5%, check if the assumptions of equality of variances is valid. Remember, we are checking the assumption of equality. Remember, meaning H node in this case, which you refer to now hypothesis, is where the variance 1 is equal to variance 2, because they said we should test for equality and the alternative will automatically not be equal to. So these are both the now hypothesis and the alternative hypothesis. So this is what we have for our studies. So going further on B, sorry, not on B, let's dive in deep in the calculations now. So immediately you come up with the hypothesis. The first or the second thing that you will do is now you calculate the test statistic. Remember, since you are checking the assumption of equality of variances, and this is simply a two population equality of variances, so meaning we are using the F test. Remember, for you to basically use the F test, you need to check if the standard deviation 1 is greater than the standard deviation 2, and basically this is how it is, which means that the formula will be sigma squared 1 over sigma squared 2. So this is the formula that we'll use for our studies. Reason being is because sample variance 1 is greater than sample variance 2. So in this case, you just replace 5.74 squared divided by 3.85 squared. So that's what you have basically. Then from here, you can just get your calculator and punch the data. So 5.74 squared divided by 3.85 squared, you basically get that as your answer, which is equal to 2.22. So this is the answer that you get when you punch on your calculator. Then from here we come to the rejection region, where we know for the fact that since we are dealing with an F test, so we'll say reject H node if what. So you look at this guy. Remember, we are testing the equality, and we always reject based from the alternative hypothesis. So the alternative hypothesis says not equal to, meaning F will be greater than F alpha divisible by 2 and 1 minus 1 comma and 2 minus 1. So this is the rejection region or rejection rule that we are going to apply in this question. So let me just take you to the lecture slide so that you basically see the rejection rules, the ones that we have chosen for this particular study. And I'm going to be there in a JFE. So these are the rules that we are going to apply. So since it's a two-tailed test, then we are basically using this guy. So this is the guy that I particularly love for my studies, and if I use this guy, I basically choose and get the guy that is above there. So diving deep in our studies, let us just go particularly to the very same question we are looking at, which is question 2. So remember, question 2 is basically there to ask us to test the equality of variances. So immediately you do this. So remember, you do not have the data that is here. So remember, alpha in your studies, you are given alpha to be 0.5. So you divide alpha by 2. Remember, n1 is basically 5. So as per study, so you basically say 4.7, and this, when you divide, will give you to be 0.025, 4.7. Then from here, we go to our Fisher table and we dive deep in our studies. So when you look at your Fisher's table, this is how it will appear on your screen. So this is particularly the Fisher's table. So particularly the Fisher's table, there are a lot, but you should always put into consideration the alpha, the one that you are going to use. So remember, for our studies, we got alpha to be 0.025. Remember, this 0.025 came as a result of the division that happened when we divided 0.05 by 2. So remember, these are the coordinates you have, 4.7. So meaning 4 is that of the row and 7 is that of the column. So meaning you have 4 here and you have 7 there. Where they coincide is where you get the number. So the number in that case is 5.5. 226. So that is what you have for your studies, 5.5226. So immediately you get this guy. Remember, they are saying that reject if f is greater than this guy. And if you check, truly f is not greater than this guy, isn't it? So meaning you can make your decision based on your answers. So if you check, you cannot reject, isn't it? So meaning do not reject H node. Do not reject H node. So the reason why you are not rejecting H node is because this guy is lesser than this guy. But if this guy was truly greater than this guy, we would have rejected H node. So that's one assumption you can make. Sorry, not assumption, but the decision that you make based from this guy. Then you make your conclusion now. So remember, the conclusion is now based on the actual claim. What was the actual claim of the question? To test the equality of variances. So if you check, due to the fact that you haven't rejected the H node, and that claim supported the null hypothesis, which means that the claim is what? Valid. Why am I saying that the claim is valid? Is because the claim supported the H node and the H node hasn't been rejected. So it's a pass. So from here we go to the second question in our lecture slide, which is question B, which is simply the continuation of them all. So using the sample results, can you conclude that the population means of the two groups are the same? So how do you basically solve this one? So remember, under the population means of the two groups, you need to always understand one basic concept. Which concept are we talking about? The concept of you understanding whether the sample size you are dealing with is greater or lesser than 30. So if it is greater than 30, then you are dealing with what is referred to as the z-score. And if your sample size is less than 30, then you are dealing with what is referred to as the t-score or t-table, as a lot may refer to it. So if sample size is greater than 30, it's the z-score, and if the sample size is less than 30, then it's a t-table. So particularly here for our studies, guys, we already know that if you check nicely, you had your n to be 5 and your other n to be 8. So both n's either need to be greater than or equal to 30, or both n's need to be less than or equal to 30. So since we know to say, okay, we are dealing with the one which is lesser than 30. So since it is equality, we are testing if they are the same, isn't it? Remember, we are testing under the assumption that the variances are equal. I state again, we are testing under the assumption that the variances are equal. Sometimes they are unequal. So if they are unequal, it's another thing. If they are equal, it's another thing. So I am testing under the assumption that the variances are equal. Please take note. So in this case, we have the t guy to be equal to mean 1 minus mean 2 divided by the root of pooled variance 1 over n1 plus 1 over n2. Where the pooled variance is never given, you need to calculate the pooled variance equal to n1 s squared 1 plus n2 minus 1 s squared 2 divided by n1 plus n2 minus 2. So this is the formula that we'll be using when we are dealing with our studies. Remember, this is just the same data that you particularly had here. So it's the same data that we are currently using. There is no change, no anything. Remember, I said, pardon me, because my equipments are not with me. So I am using freehand to basically create the video for you guys. So we continue, where n1 was 5 minus 1, and the pooled variance in this case was, the sample variance 1 was 5.74 squared plus 8 minus 1. So you can just get the data from above to prevent flipping of the page anyhow. So squared divided by n1, which is 5 plus 8 minus 2. So in this case here, we know to say the subtraction of 5 minus 1 is basically 4. And 5.74 squared. So 5.74 squared is basically... So, okay, in short, let us just do it directly. This times that is basically equal to 131.79 plus then 3.85 squared is equal to that answer by 7 is equal to this answer, which is 103.76 divided by 5 plus 8 minus 2 is basically equal to 11. So that's how basically you calculate the value which has been highlighted here, the one which we want to highlight, 1.3179 plus 103.76. So it is basically 235.55. Yeah, so this guy, we divide him by 11 now. So divided by 11, you get the guy to be equal to 21.4. So the put variance, the one that we are using, is basically 21.4. So this put variance is the one that we will basically put there. Remember your mean is basically 79.52. Your mean 1 and your mean 2 is basically 70.75. Then you square root 21.4, 1 over, remember n1 in this case is particularly 5 plus 1 divided by 8. So we continue a bit. So 79.52 minus 70.75, you particularly get 8.77. Then from here you can just go directly 1 divided by 5 plus open bracket 1 divided by 8 times 21.4. Then you get the root of it. You get the answer to be 2.637. So 8.77 divided by 2.637, you get your answer to be 3.325. I stand to be corrected. Kindly verify my work as you are punching as well. I stand to be corrected. So immediately you calculate that, we come to what is referred to as the rejection region. So we are rejecting H naught if, remember we haven't yet, remember we are also testing if they are the same, isn't it? Meaning H naught mu1 is equal to mu2, and the other one, which is alternative, mu1 will not be the same as mu2. So in this case we are testing if alpha is greater than or equal to T alpha divisible by 2, n1 plus n2 minus 2. So this is the formula that we'll use to particularly reject the H node if this guy is greater than the other guy. Where remember for our studies we are using 0.05, which when you divide by 2 will give you 0.25, and here you will have 11. So we get this and go to our T table. So let's go to our T table, guys. So you look for the T table in our machine. Yeah. So in this case, let's just zoom out a bit. So we remember, for you to know whether it's a one tail or a two tail, you need to check the sign on the alternative. So the sign on the alternative, remember I said, is not equal to. So it's not equal to, we are using a two-tailed test, and it is 0.025, meaning we are using this guy. Remember 0.05 is the same as 0.025 under a two-tailed test. But someone may be like, but no, he used 0.05 instead of using 0.025. Quite of course, I can even show you proof towards why we can use. So just say 1 minus 0.05, you get 0.95. Then you divide 0.05 by 2, you get 0.025. Then you add the same 0.025, it gives you 0.975. For more proof and context, the 0.95 is here. This is the 0.975. You have seen the main reason why everything is correlating. This is mathematics, guys. Yeah, so this is how we are solving this question. So it is 0.025, 11, which is quite there, which is 2.201. So 2.201. So this is how we arrive at the answer here. So when you check if this guy is greater than this guy, we are rejecting. So look, this guy is truly greater than the other guy. So meaning the decision that we should make is to reject H node. Why? Because the statement is true. So reject H node, which means that the conclusion, according to the rejection itself, you can tell that the claim is false. So the claim is invalid. The claim is invalid. Yes, so this is how particularly you solve that one. Going further to the question, there is another part which is interesting, which has been left unattended to, which is C, which I will not elaborate much. So construct a 95% confidence interval for mu1 minus mu2 and the ratio of population variance 1 to population variance 2. So remember the ratio as we articulated earlier in our preamble. We said it will be variance 1 divided by variance 2. So it will be 5.74 squared divided by 3.85 squared. So that's what we have. We have 5.74 squared, which we get to be 32.9 to 3. Let's put our calculator there. 3.85 squared, which is 14.8. Remember, it's a ratio. You can just reduce these to their lowest term. Do not divide, please. It's a ratio. Understand the mathematics language. So now for you to basically construct the 95% confidence interval, we basically use this formula for this question: plus or minus T alpha divisible by 2, N1 plus N2 minus 2, the root of sample put variance, this guy. This is what you have. So this is the formula that you will use for your studies. You have everything here. This guy has already been calculated, is 8.77. So 8.77 plus or minus this guy has also already been calculated, which is 2.201. And this guy has also been calculated, which is here, which is 2.637, has already been calculated, is here. We have just calculated the values there. Then I believe from here you can continue the question, and this is how I have helped you guys. Your host, Golden Zulu.